Hello and welcome back to another episode of Math with Son. Today we're going to be continuing physics and we're going to be talking about collisions, okay? So when we're talking about collisions, there are two different types. There is an elastic collision and an inelastic collision. And it's important to distinguish between the two. And it's always important to, before that, to realize that when we're talking about elastic versus inelastic, we're referring to an isolated system. Now, I know that Earth is truly, not really isolated because of gravity and some other things that would affect it. But you can isolate and you can control whatever system you would like. For instance, if you want to talk specifically about two cars or two balls or two of anything or three of anything that could run into each other, that's your system. All right? So, momentum of an isolated system is always conserved. So that is the law of conservation of momentum that we talked about before. And that means that the sum of the initial momentum will equal the sum of the final momentum. And both of those are vectors, okay? Energy, however, may or may not be conserved. In an elastic collision, kinetic energy is conserved, and the objects that are going towards each other, let's say you have like two marbles going towards each other, when they collide, they will go away from each other perfectly elastically. No energy will be wasted in the form of friction or anything else. Okay, so the quantities conserved would be momentum, which is P, and kinetic energy, which we could call either Ke or K. All right? So, if it's an inelastic collision, kinetic energy will not be conserved. Typically, we talk about that when two objects interlock and collide, that deform. They will have things that stick together, and all of the stuff that's happening at the microscopic level or in friction or whatever, energy is lost due to heat, deforming of the object, or the fact that the energy that was moving with the momentum just was transformed into some other kinetic energy that caused a sound. A sound is technically energy. All right, so anything that happens with that would lose some kinetic energy and therefore would be considered inelastic. All right, you can think of elastic as like a rubber band. It's going to be wing, wing, going back and forth, versus inelastic, it's going to have some sort of deformity and some sort of energy that is lost. All right, the thing that will continue to be conserved, though, is momentum. Momentum is always still preserved. All right, another thing that is kind of cool is collisions can still be considered inelastic even if there is no apparent deformation. You must check to see if the energy after the collision is the same as the energy before the collision. And if it is a perfectly inelastic collision, the objects will completely stick together and move as one mass. All right, so that's kind of cool. If you think about like whipped cream, something. Let's say you were throwing a ball at let's say you were throwing whipped cream at like a ball. What would happen to the whipped cream? It would just get splattered onto this ball, and then if it had enough energy within the whipped cream, the ball and the whipped cream would kind of move as one because the whipped cream would just completely stick to the ball. All right? So we got some examples here. Identify the following collisions as elastic or inelastic. Now, there is some gray areas with this because you could argue that all of these are inelastic. It's almost impossible to have a real elastic collision. All right, so two marbles slide towards each other, hit each other, and then bounce away. If they bounce away and don't make any sound and don't have any friction in between them, they would be considered elastic. All right, it would be an elastic collision. However, if you had two rental cars driving at 40 miles per hour on I-95 and they crash into each other, interlock, and stick together as they slide off in the same direction on the road, both drivers and passengers escape unscathed and apparently are going to Canada because they're on I-95, probably in Florida. So with that in mind, this would be as close to a perfectly inelastic, wish I could spell, inelastic as we could hope for. The next two are kind of the gray area, especially the golf ball. A football, I'm going to start with the football. A football kicked by a foot is sent flying through the air. All right? The foot received just as much energy as the football did because of equal and opposite reactions. But when you think about kicking a football, as it happens, when your foot kind of makes contact, that football kind of indents a little bit. It deforms. The air is compressed. And when that happens, you have an inelastic collision because there's a deformity. The argument with the golf ball is golf balls also kind of deform a little bit. This is still considered inelastic, but it is edging towards an elastic collision because the golf ball itself is way less squishy than a football is. The more squishy the object is, the more inelastic the collision will be. All right? And lastly, we got a 5 kilogram mass hits a wall with a speed of 5 meters per second and rebounds with a speed of 3 meters per second in the opposite direction. What is the change in kinetic energy? Okay. Well, that's not the main question yet. But in general, we have 5 kilograms that was going at 5 meters per second, and now it's going at 3 meters per second. Is it going as fast as it was before? No. Therefore, this is by far an inelastic collision. And if we wanted to figure out the change in kinetic energy, well, change in kinetic energy would equal the kinetic energy of the initial minus the kinetic energy of the final, or flip-flop. That would actually produce a negative if it goes down. So final minus initial. And kinetic energy is, of course, 1/2 mv squared. So, with that in mind, we are going to do 1/2 times 5 times 3 and compare that to 1/2 times 5 times, squared, times 5 squared. And if we do that, we get half of 9 times 5. I need a calculator. Where's my calculator? I've lost the calculator. I am sad. Where did my calculator go? All right, I can do it by hand. We get 5 over 2 times 9 versus 5 over 2 times 25. And if we were to do that math, this is equal to 45 divided by 2, which is 22.5. This is equal to 12.5. 125 divided by 2, which I believe is 67.5, thus having a change in kinetic energy of 25. That would be the change in kinetic energy. All right, that's going to do it for this one, Newtons. Until next time, stay positive, my friends. It will continue to get easier until it gets better for you. Stay positive. I'll see you there. Bye.